We'll talk about writing a compiled plugin for NADI system. So NADI system has two kind of plugins. So there is like executable plugins that are basically just their own program. It can be Python or like any programming language or anything really, and you can just call them from inside NADI. So if I open NADI ID, so we have a function called command. So when you run a command function, you can give a command and then it will just run that command in the cell and then give its output. So like basically very simple. So we load this network. So if I do node command and then if I run Python here, then it will just run that command. If I run echo something, then it will run that command. So let's also echo the results. So echo something ran and gave something. If we run version, then it will give the, so it's running it for each of the node. So you could put name, so it will run it with name of the node. So that's how you can pass different parameter. So any program that can be called from the terminal with arguments, command line arguments can be called with this function. So without the echo, we did see that when you run something, it just does not give any output because normally it suppresses output unless it's relevant. For example, if we echo NADI variable equals to and then let's do order. So if you run it, then it will give a result because whenever the standard output has a NADI variable prefix, then it will interpret anything after that as a key value pair of like updated value for any variable. So this thing will be read from the NADI. So now when you do like run it here, you can see those values are updated here. So you can use this method to run any programs, like you can write Python script that reads files, like does a lot of, you can use any Python libraries, you can do any kind of analysis, and it can save like transfer those values for certain variables through standard output by using this syntax. Anything else on the standard output and standard error will be ignored. So this is like a easy way to write Python program, like Python plugin. Let's try something. Yeah, let's try to make something. Okay. Okay, so let's make demonstration. Okay, so we have nothing, so let's do, so if we run a program here, let's try making something this task, and then we'll make plugin. Okay, let's just say capitalize that by. Okay, so first thing we need to do is take command line arguments. So you can do this through this, you basically say like equals to this, and if there is no set index error, then you do okay. Now what you will do is arg capitalize, and then you just print it. You will NADI bar yeah, this is super simple example, but basically like you can do anything, you can run anything. Okay, let's run NADI ID here. Let's open. Okay, so if you do node command python get fine. So right now it doesn't have any nodes, so we do load. So everything is run on a network, so without a network like nodes function will run nothing. So it ran Python capitalization and it did not do anything because it ended in error. So if you try my name, then it will run it with that function. So yeah, I did not. I think capital yeah, or we made a mistake with the name. Okay, so it says parse error unexpected token because capitalize needs, it's a string, so it needs to be quoted. Or we could use this for Python. Okay, so now if we run it, okay, it's giving error line 1 column 1. Oh, so we cannot have variable name as output. So this basically has to be something you can run like this. Output equals to something. So output is a keyword, so we cannot have a variable called output. So it was unable to parse. I think I need to put something here like I definitely need better error, but let's say result. Okay, let's run here. Okay, so now okay, forgot to save. So now when we run it, we get capital name. So we can try anything here that could be like name that will change value of results from my name to like capitalized version of their name. So this is like super simple demo. You can write like any kind of Python program, and as long as you have data format that you can transfer back to NADI, you can do it. So this should allow you to run any complex functions. And as you see, like the benefit of the executable plugins are that you can just change those and run it again, because every time you run it, it is running that file. So it's not saved in the memory, so you can like do faster prototyping and everything. So another way to do the same thing is through compiled plugin, but compiled plugin are loaded at once. Like whenever you open NADI, so you cannot reload it while you are running NADI. So anything here like in the function help, anything with capital name is like are the plugins that come with NADI. So those are internal plugins, and these functions will be available to be called anytime. So you can just do 1 2 3. Let's start from, I don't know, infinity. So minimum is 1. If I start from minus infinity, minimum will be minus infinity. So yeah, you can run these functions anytime, but for external plugin, right now there is no external plugin. You can see external plugins, whenever you load them, you can also use them. We'll try to make one right now and then see. Okay, let's go back to our terminal. So for making external plugin, you can use the NADI. So there is a command called new plugin that comes with NADI. It will write all the boilerplate codes, it will write any other requirements, etc. And if your NADI core is in a relative path, in it's like you can also provide that. So let's do NADI JSON. We'll try to write a simple library that loads JSON file into NADI attributes. And if you do it with this currently, it will write NADI JSON directory. So it will write 0.8 version, which is not available in cargo yet. So you can do the same with 0.7, like whatever NADI version you are using, it will generate boilerplate code using that version. So for this, I'm gonna do NADI code for me is here. So I'll use that. First, I need to remove old files. So if I do this, now I have these files. So it has the path for NADI core, and then it has the code for the plugin. There are some helps, and then you can write 3 types of function: environment function, node function, and network functions. All of them can be defined. So if you load a network, so if you do if you call environment function, then it is only executed once, and node function is like if I do the same thing, it is executed for each node. So you can call environmental functions as a node function. It will just run with the same argument, but the benefit of node functions are like node has attributes, so you could technically use them like this. So if you do this, every time this environment function is called, it uses different parameter. So as long as your function only depends on values, it's better to write an environment function, so you can call the same functions in all contexts. So you can also call them from network, but now it will have error because we cannot take node attribute in a network function. But if we had any attribute here, we will be able to run it, but we don't. So we can say network. So if your network has an attribute, then you can call the same functions in all contexts. But some specific functions, like if network has save file, it can be called from here, but of course right now it needs file path. So let's just test something. So it can save the file, but if you try to call that functions for each node, you will get an error because save file is a network function and node context will search for a node function called shapefile or an environment function called shapefile. So since that is not available, it cannot run it. So uh, environment function can be run anywhere. It just takes certain attribute values and returns a value, or just doesn't return anything, does something. Node function and network functions work within each node or within the whole network, and then they can internally read node or network attributes, connection, and any other information, and they can also modify them. And environment function can be used anywhere, like they can be combined. So you can say sum of 1 to, you can call this environment function and then still combine other things. So you could do the same thing with node, or you could do node order. So those are the differences between these three kind of functions in terms of like what you can do. So if you can write something as an environment functions, do it. It will take any parameters and then return something or not return something. If you cannot do it, if you need access to node connections and other information, then you can write a node function that will take node data type, or you can write network function that will take network data type. So right now, so we have the files. Let's go to here. Since we have to use this name, I'm gonna shorten it, and we can just do cargo build. So this will compile our plugin. Right now I haven't changed anything in the plugin except the name. So it will compile with these default functions that came with it. And since we need to reload NADI, we will close it, and once it compiles, we will copy. So we have the .so file here. That's our CR library. So we'll copy that into NADI Plugins directory. So from version 0.8 onwards, each version's plugin go into their own folder. Before that, it was in the same place, so you couldn't have multiple versions of NADI. But from now onwards, you should be able to have multiple versions of NADI. We'll copy it, and when we run NADI IDE next, we can look at the functions, and if you search JSON, then we have these three functions that come from our plugin. So let's try to change things here. Let's remove this. Okay, so we'll write an example function that loads JSON file is a attribute map. We don't need any default parameters. We need file name or file path, and we'll call it load JSON. We'll use and we will return. So there could be error. For error we can use anyhow. Okay, this should okay, right now it doesn't do anything, so let's see. Let's compile it and copy it. So when we open the IDE, Yeah, if we search JSON now, we only have load JSON, like same code we have typed, like NADI plugins will save the code so anyone can look at it and then modify it and make their own plugins. Because plugins are compiled, they are binary, so people need to be like able to see what they are running. So it saves that code, but it can still be obfuscated. So like don't run plugins that you don't trust. Now if we okay, so if we do json dot load json, we don't have any files, so let's make this data. Okay, right now it did not, I guess, did not really need anything because it was just return an empty attribute map, but we want to be able to load the actual file later. So let's save this. Now we need to modify this code so we can load it. So first thing we need to do is add JSON library. So yeah, we are not going to be writing JSON parser from scratch. We'll just use a library, we'll just use what it has, and then we'll use that data to, like, we'll use that logic. So we'll do, yeah, of course you need to like look at the file types and the API for whatever library you are using. I will try to keep it short. So we write a helper function that converts JSON to attribute. It will take JSON value and then it will return attribute. So since JSON value has all these types, we just copy it. Okay, so yeah, first problem is we don't have null in NADI, so we have to return option. Let's do this. Don't need return here. Okay, so this will return none and everything else will return something. So we'll return attribute. So for these two, so yeah, sort seems to be basically a string that's really short. So we'll just do string. For the plugin system to work, we don't have stable ABI for Rush, so we are using ABI stable, so it uses a different string than regular Rush, like standard library string. So we have to convert that. Boolean is, we have Boolean type. Array, we have array type, but so probably have to do recursively call JSON to attribute and then we collect it into option vector of attribute, and if it is option we return it's none, we return none. Otherwise we can convert it into picture. Okay, sorry, should not have said it. And we have to do something similar here. We return a table. I looked through the documentation on what this object means. It does not have into iter, but it has iter. So we are gonna be removing this. And it has key and value, and we will run this on the value clone and then map it into key. This value into key value pair. So this we can convert into, this is the format, that's the string we are using, so we have to add that. Okay, so number, for number this seem to have like single type of number, no distinction between whether it's float or not. Okay, so it can be converted into float and it can be converted into okay, so you can convert number into I64 and it might result in error, so we can use that. We can say math I64 try from value, and if it is okay then we get attribute integer. If it's an error then we again try F64 and we only have to take, if it's error we can just ignore that and return none for now, and then we map into attribute float. This returns an option, so we do return here okay. Okay, so this should be able to convert most of the value. Let's see. Okay, now first thing we do is contents. We'll just read everything to the string and then we do everything to JSON. And then we do JSON to attribute, JSON data. Okay, or not supported in NADI. Okay, so let's try to compile it. Okay, so it is going to be returning attribute. Okay, we need to do better job here. Okay, it compiled and we copy it there. We need to close this and we need to open it again. Yeah, so if we load now, it's saying no such file or directory. We wrote test.json, so it's okay. So it was successfully able to load the file. We can change the content. We can try different things. And when we run it again, it should be able to load this. So now it is like saved into NADI attribute. You can save it into the variable and then you can access it with dot syntax like this. So yeah, so it was like we only wrote a environment function, but you can see how you were able to write a plugin and then load it, and then you can like look at the documentation. Right now we don't have much, so you can look at the code. So it doesn't let you know what's happening inside this JSON to attribute function, because that's where most of the thing goes. But the plugin saves code for this block. So if people want to hide what their code does, or if they want to write functions that can be reused, they will write it separately. I like recommend using code that you can see, so you know what's going on, what it is running, or even if you don't, at least someone else will. So yeah, now we can use the same method, and if you want to write node function, you can use the same thing, but it will have let's write a node function that loads JSON. So environment function cannot write anything. It can only like return values, but with node function we have access to this, and then we can simply return this. Now what we can do is node let's see if it runs. Okay, instead of returning attribute, it should be returning. Okay, JSON can be like anything. So for you to be able to load JSON and then save it as a network attribute, it has to be a table. So we can do this, and if it is attribute table, then we can do this. Everything else, let's do this. Everything else we return. Okay, sum A. Okay, now. Okay, let's compile this. Did not compile because I have to do it. Okay, so it compiled, so we copy this file and then we have to restart NADI. So when you run an environment function, it just loads those files. But now if you run a node function with the same name, it does not output anything, but it is writing node attributes from the JSON value. So this part is not as useful, but if you have something more significant, then you could do like only save it for node A. So this way you can like, okay, let's restart. So if you only do it for node A, then only node A has the value loaded from the JSON. So you can like manually load something without having to like run multiple functions. You can do that, but as we have in the logic, it needs to be a table. So for example, if we change this, okay, we can, if it's an array, then if we try to run this, this will just show the array as output instead of like loading it inside. So yeah, that's it. Again, if you don't select node, it will run for all the nodes. So you can do like this was a simple example. You can do more complicated things. You can write different plugins. We have some plugins available that are available here. So you can look at them. You can see what's possible. Like these are mostly just simple examples. Like so you can get these from NADI system GitHub. There is NADI Plugins Rust. NADI system NADI Plugins. So if you go to this repo, there are some example plugins that you can look. For example, the HTML plugin will simply generate a HTML file given your network and then something, and it can also like create a SVG using your network information, so it looks nice. If you want to use any plugin, all you do is just git clone and then compile it and then copy into NADI directory like we did here. That's it for plugins. You can test things out, you can explore, you can see what's possible. The main reason plugin exists in NADI system is because the language is still developing. So it like even and it's dynamically it's like interpreted language, so it's not as fast if you write functions. It's not available in NADI 0.7, but for NADI 0.8 we are defining function syntax, so you can write functions that take values and then return okay. Okay, so it will be coming soon. So this is how you will define a function, and then you can call it. So users can only define environmental functions. So you can call it from here. So since you can only define environment functions, so you cannot mutate node or network, but you can use any values from nodes like this. And if you want to mutate a node, you can simply assign a value like this. So environment functions basically can still take inputs that varies between different nodes and can save outputs to different nodes. They just don't do it like internally, but node and network function can do it internally, which can be sometimes not obvious. So if it's possible, if it is easy to do it, then it might be nice to write functions that can run by taking any value, so you can call it from any instance. So if you wrote, for example, a function that takes order from node and does something, and if you write it just like this as a node function, then you might not be able to call it as a network because the internal data type and internal representation will be different. That's it for plugins. Thank you for listening.